Now I got a scalable storage. It's a cluster. It may be a few dozen machines. And then my question is, I'm used to writing my software for a single server, and that won't work. Because if my data is on 100 machines, then probably my single server won't be able to do this. Well, think of what is the best big data processing engine. We can do such search for fun. I'm quite sure that one of the top that will come up will be Spark. So what is Spark? Spark is a kind of a new Hadoop. You can think of it this way. It's in-memory big data processing engine of Hadoop. You can compare it to some old cartoon ideas about PC and the Mac. But the end result is that it takes all of your data here on the left, and it brings it into memory. Here we show those memory blocks being 64 megabytes. They're called partitions. And then it does this processing in the memory, and that is much faster. So the amazing thing, and that's the bigger point here, is that yes, I have my storage, I have my search engine, but how do I process it? Well, you can combine this with Spark, and Spark will give you the capability for very fast processing. So let's continue. I prepared 2 labs. Now, a disclaimer, labs never work. That's my rule. Whenever you're trying to show something, that probably something will break. Nevertheless, I'll try to do this. And if it doesn't work, you will have the fun of seeing me fighting with that. Let's do this now. So first of all, let's open that lab, which I prepared for you. There you go. It doesn't work right out of the box. But for that, I know what I need to do. I'm just hitting in and I'm starting that server. Now that lab should work, and it does. I should be able to even get out of here, and it should still work. Yes, it does. Very good. So in this lab, I want to show you how you would install the basics. I actually did it already, but I want to show you how easy it is. So the first thing is we unzip Spark, and then we call it Spark so that we can start our Spark in an easy, simple way. But the next one is different. You need to make Spark and Elasticsearch work together. For that, you need to get a library that will be living in between them, and that's called Elastic Spark right here. So here you would get it from, in my case, I prepared it on S3, but you would get it from Elasticsearch, and then you would start the Spark shell, but this time you're starting your Spark, and you are also giving it a jar where you want it to run. So here's what I'm doing. That's the command that I need to do in order that I can talk from Spark to Elastic. Let's do this. Okay, I'll make it bigger so that you can see. I'm logging in again, just like I already did. And then I'm starting Spark in this special way, as you can see, where I'm saying, and use this additional jar. So let's see if it works. Okay, we have it. So we can do things like help, just for fun. But that's not important. What is important is that I want to take my data and write it to Elasticsearch from Spark. Here's what I'm going to do. I'm going to form my data. So first the necessary inputs, and then I need to tell one interesting thing to Spark. Here, I have to tell the search engine that if I'm putting the data into a table that never existed, more correctly, into an index that never existed, then it should create this index on the fly. That's easier that way. Then I can create other necessary inputs. from Elasticsearch, as you can see, and create some data. This data I will create right here in memory, like this. So I created numbers. This is a simple collection, but it has all that the search engine needs. It has a key and the value, a key and the value. I should be able to search that. That's the numbers. There are also airports, just to show that I can have a different data structure, and that has string to string. So it has the key and it also has a value. Good, so I created some data just to demonstrate that yes, indeed, I can write straight into a search engine from Spark. And here's the command to do it. That's the command to do it. That will write into a Elasticsearch. How do you know it writes to Elasticsearch like this? So that's one of the cutting edges today, because even to find that documentation wasn't easy, and some of that I had to dig up and find it in the code. But then once you are there, then you realize, yes, that's how it works. And actually from the code, I was able to then search and find the documentation on the web as well. So what did we achieve? We showed that you can match one cluster against another. What we've done so far was this. We can use Elasticsearch for storage, and that's great. We can also try to match the capacity of the storage with the capacity of the processing, and that we do with Spark. Now I can create a huge cluster of storage, let's say 100 machines, and another huge cluster of processing, and that's Spark. And in order to test that and verify that I can store my billions of records, I will run that as services on Amazon. That right now I'm not showing because it will take more than just a few minutes to start. But you can experiment in any cloud actually this way. If I want to see that, yes, indeed, I got this search engine running, then I can try to just list data in my search engine. That's how I usually do it. I'll get out of Spark, list the data in the search engine, and you see that same data. You maybe noticed that's the airport that I have just put. So that short demo was to show that yes, you can indeed match the processing of the cluster on one end with the Spark on the other end. The other demo would show how you do it in the modern version of Spark and how you would be reading lots of data from the hard drive.